Let's take a look at this example. Please notice that in this problem, all resistances are given. So we're going to start solving this problem from solving total resistance. Please notice that resistors R2 and R3 are connected in series. So that's why I'm going to add these two resistors first to find resistance R23. So I have R23 is equal R2 plus R3. I have to add them up because both of them are in series. So I have 800 ohms plus 3 kilo ohms. This is equal 3.8 kilo ohms. Okay? You can redraw the circuit and you will have voltage source, you will have resistor R1, and you are going to have resistor, which is combination of these two resistors, R2, 3. Now you can see very clear that these two resistors are in parallel. Because I have just two resistors, I can use the formula called product over the sum. So R total, in this case, is going to be R1 times R23 over R1 plus R23, where R1 is equal 10 kilo ohms times R23 equals 3.8 kilo ohms over 10 kilo ohms plus 3.8 kilo ohms. So everything is equal 2.75 kilo ohms. Okay, so this is the total resistance of my circuit. Next, I have voltage source. I found R total, so I can find very easy I total. I total, right, is nothing else just voltage source over R total. Because we can redraw this circuit, and the circuit is going to look like this right now. I have a voltage source and I have R total, right? So in order to find I total, I'm going to use Ohm's law. I total is equal voltage source over R total. So voltage source is equal 45 volts over R total, 2.75 kilo ohms. Everything is equal 16.36 milliamps. Okay, so this is my I total. Next, I'm going to find I1. Please notice that resistor R1 is in parallel with the voltage source. So voltage source is going to appear across resistor R1. So again, I'm going to use Ohm's law to find current which goes through resistor R1. So if I1 is equal voltage 1, which is equal to voltage source over R1. Okay, don't forget that in parallel circuit the voltages are the same. That's why voltage source is equal to V1. Okay, we can write on the side that voltage source is equal to V1. Okay, so we can say that we found V1. V1 is equal 45 volts over R1, 10 kilo ohms. So I1 is equal 4.5 milliamps. Okay, so this is the current I1. Because I have voltage, current, and resistance, right? If it comes to resistor R1, I can find very easy power 1. P1 I can calculate from the formula with the current I1 squared times resistor R1, where I1 is equal 4.5 milliamps raised to the second power times R1 10 kiloohms is equal 202.5 milliwatts. Okay, so this is power 1. Because we have given voltage source and we found I total, we can find the total power. P total is equal I total times voltage source, where I total is equal 16.36 milliamps times voltage source 45 volts. Everything is equal 736.2 milliwatts. Okay, so this is the total power in my circuit. Okay, so I'm going to cross this one out. Next, we're supposed to find the current which goes through resistor R2 and current which goes through resistor R3. Please notice that these two resistors are in series, right? We mentioned this before, but many students have tendency to forget or get confused. These two resistors are in series, okay? So we have just one path for current to flow, okay? So means we are going to have one current, which we are going to find by simply writing that I2 is equal I3, we can also call this I23, is equal voltage source over R23. Okay, supposed to use Ohm's law. Voltage source divided by resistance R23, which is combination of these two resistors, is going to give me the value of the current which will go through resistor R2 and resistor R3. So voltage source is equal 45 volts over R23 we found is equal 3.8 kiloohms. So I2 is equal 11.84 milliamps. Okay, so I2 is equal 11.84 milliamps and I3 is also equal 11.84 milliamps because these two resistors are in series. So we have currents, so we can find the voltages because we have also resistances. So V2 is equal I2 times R2, where I2 is equal 11.84 milliamps times R2 800 ohms. This is equal 9.47 volts. Okay, so this is the voltage drop across resistor R2. If I have current and resistance, I can also find the power. So P2 is equal I2 squared times R2, which is equal 11.84 milliamps raised to the second power times 800 ohms is equal 112.14 milliwatts. Okay, so this is power at resistor 2. So we found V2, we found also P2. Okay, and we found also I2 and I3. Next, we are going to find the voltage VAB. Voltage between these 2 points, A and B. Please notice that this is nothing else, just the voltage across resistor R2. And we can say that we found the voltage across resistor R2. Okay, this is equal 9.47 volts. So we can say that, let me write this over here, VAB is equal V2, which is equal 9.47 volts. Okay? So we found VAB. If you want to find V3, let me write this over here. V3 is equal I3 times R3. I3 we found is equal I2, this is 11.84 milliamps, times R3, 3 kiloohms. So I have V3 is equal 35.52 volts. Okay, so this is the voltage drop across resistor R3. If you want to verify that our answers up to this moment are okay, you're supposed to add V3 to V2. If you are going to add these two voltages, you're supposed to end up with 45 volts. So 35.52 volts plus V2 9.47 volts is equal 44.99 volts. So it means that our answers are correct up to this moment. Okay, so the sum of these two voltages is equal 44.99, voltage source is 45 volts, so everything is good. Next, we're supposed to find the power P3. P3 is equal I3 raised to the second power times R3. This is equal I3 11.84 milliamps times R3 3 kiloohms is equal 420.55 milliwatts. Okay, so this is the power at resistor R3. If you want to verify your answers, you're supposed to add all three powers together. So P total is equal P1 plus P2 plus P3. I mean P1 202.5 milliwatts plus P2 112.14 milliwatts and P3 420.55 milliwatts. It's supposed to give you the answer 735.19 milliwatts. Okay, so compare this answer with P total, which we found before. So as you can see, these two values are very close to each other. So it means that our calculations are correct and the problem is solved.